So in this video, we continue with activity 1.4. I believe we finished problem 6 in the last video. So we're going to move on to problem 7. So it looks like we have Charlie. He tells us he weighs 180 pounds and his weight has not changed. So think about that. His weight has not changed. All right, so when I'm thinking about the average rate of change, well, if his weight hasn't changed, the average rate of change would be 0, or the slope would be 0. So it says, what is the rate of change of Charlie's weight? I'm going to say 0 pounds per week. Right? So his average rate of change, or the slope, would be 0 pounds per week. If I look at question number 8, write the linear equation in the form of y equals mx plus b. So again, his initial weight was 180 pounds. So my b would be 180. And the slope, or the average rate of change, would be 0. So we have all of the components we need to write the linear equation describing Charlie's weight. So it would look like this: y equals 0x plus 180, right? Because the slope was 0, the 180 was his initial weight. So I think we can also write this as just simply y equals 180. Right, there's no need to show the 0x. Let's take a look at question 9. Okay, so they're going to ask us to graph the line representing Charlie's weight. So again, on the spare piece of paper, let me write down the equation for Charlie. We've already done Alan and Bill in the previous video. Right, so these are the 3 equations, Alan, Bill, and then Charlie is really going to have a straight line at y equals 180. So here's my line that would represent Charlie, this red line. And I'm going to add that to my calculator. So if I press y equals, remember we had Alan and Bill's equations in our calculator. So Charlie was the y equals 180. And then I press graph. And there's Charlie's line. Now you might say, how come my calculator doesn't look exactly like what we have in the book? Well, if you look in the book, notice that their first tick mark is 155, and I think ours, we started at 0. So if I change my window and I go down to y minimum, if I started at 150 or 155, let's use 150, and then I regraph, you'll see that my calculator graphs now look a little bit more similar to what was in the book. Right? It spaced it out a little bit. Okay. So question 10, it says on a grid above, graph a line that contains all the points corresponding to week 5. So here's week 5. So we need to draw a vertical line going through week 5. So I inserted this yellow line going through week 5. And it says, what type of line is this? Well, this is a vertical line. So I'll type in vertical line. At week 5, write the weight of Alan, Bill, and Charlie. So Alan's weight at week 5, it looks like he's 170 pounds, right? So this diagonal here is Alan's weight over time, and at week 5, he's 170 pounds. And then we have Bill, at week 5, this line that's sloping down was Bill's equation. Remember, he was losing 3 pounds per week. Looks like he's 185 pounds at week 5. So I'll type in 185. And perhaps I should put in pounds, right, the units. And then Charlie, well, remember, Charlie was 180 pounds. His weight didn't go up, it didn't go down. He was always 180 pounds. And if you look at week 5, there's Charlie's weight, 180 pounds. Right? So write the equation of the line that represents week 5. Well, this vertical line would be x equals 5. And let's just change the color there. Right? So the equation that represents this yellow line would be x equals 5. Now we have Dan. Dan claims his weight is given by the equation 3x plus 2y equals 348, where x is the number of weeks. So it's asking us to rewrite this equation in y equals mx plus b form. So we'd have to bring the 3x to the right side of the equal sign, then divide everything by 2 to get y by itself. So let's do that. So my first step is to subtract 3x from both sides, leaving me with 2y equals negative 3x plus 348. Now to get the y by itself, I'm going to divide everything by 2. So if I divide each piece by 2, I end up with y by itself down here, where y equals negative 3 over 2x plus 174. Or you could even write y equals negative 1.5x plus 174. All right, so this is the equation now written in standard form, or y equals mx plus b form. 14, what's the slope of this line? So the slope is the value that comes before the x, so it's negative 3 over 2. All right, so the slope is not 3, but it would actually be negative 3 over 2. And the practical meaning would be Dan lost 3 pounds every 2 weeks. Or if you wrote 3 over 2 as 1.5, you could say Dan lost an average of 1.5 pounds each week. All right, so here's the practical meaning. Right, again, Dan lost on average 3 pounds every 2 weeks, or Dan lost on average 1.5 pounds every week. And again, he lost weight because the slope was negative. The y-intercept of this line. Well, again, let's go back to the equation. The b was 174, so the b is 174, or the y-intercept would be 174 pounds. Oops, 174. So we could say Dan's initial weight was 174 pounds. As an ordered pair, we could write 0, 174, right? At week 0, his weight was 174 pounds. And the practical meaning just, again, is Dan's initial weight was 174 pounds. So now it says, use the equation in number 13 to estimate Dan's weight at week 5. So here's the equation from number 13. So to estimate his weight at week 5, we replace the x with 5. Remember, this equation tells us the weight at any given week. So we know the week. The week is 5. So I replace the x with 5, and that will tell me Dan's weight at week 5. So this is what my new equation will look like. And if we do the math, if I take out my calculator, I can actually type this exactly as we see it. Negative 3 over 2 times my 5 plus 174. And you see I get 166.5. So Dan's estimated weight in week 5 is about 166.5 pounds. So I think we'll stop here. We can read the definition before we go. So slope-intercept form is y equals mx plus b. And I guess the standard or general form is this ax plus by equals c. So we were in standard form where we had this 3x plus 2y equals, this would be our c, right? Think of this as ax, by equals c. But many times it's more useful or more convenient to be in the slope-intercept form, or y equals mx plus b.